Welcome to the DataStack Show. Kostas, today I'm so interested to talk to our guests because it's a subject that I actually don't think we've covered before, which is user-facing analytics. Kishore was one of the creators of Apache Pinot, developed that. It was a technology that came out of LinkedIn that really drove a lot of their user-facing analytics. And I'm just excited to chat about that because we have new subjects. But one of the questions I have is, we talk so much about analytics in terms of, whatever reporting inside of a business, KPIs, et cetera, developing analytics for users, executive team marketing, et cetera. And I want to know if there's a big difference in the way that you think about user-facing analytics and developing that. And then, of course, like the technology around it, because obviously they developed Pinot to sort of, deliver those in the context of LinkedIn. So that's what I want to ask about. How about you?
Yeah, I'm very excited about our show today because we are touching a category, a subcategory of analytical databases that we haven't touched in the past, and these real-time OLAP databases. And Pinot is one of them. There are a couple of others, but it's the first time that we are going to discuss about that, and I'd love to learn more about what makes them unique, both from the use case perspective, because what you mentioned is one of the use cases that uniquely serve these systems, but also from the technology perspective, what makes Pinot different than BigQuery or Snowflake, for example. So yeah, I'm really looking forward to chat with our guest today.
All right, well, let's dive in. Outro. Sorry, keep it rolling. Kostas, I think the thing that I really took away from the challenges related to user-facing analytics was just the concept of, let's say 50 million people doing something at the same time and then needing to basically be delivered, some sort of result from a computation, right? How many people viewed your profile, et cetera. And it's just wild to think about that level of scale with that little latency. It's really just insane. And so, it sounds like a really challenging problem that they solved. And Pinot, seems like a pretty amazing technology to do that. But yeah, it's just kind of not the type of problem that you face, that you face every day.
Yeah, it's. I really enjoyed the conversation that we had because it's one of these cases where you have, let's say, a use case drive some extreme optimization of a system that almost leads to a new design. To new design principles of how to build database systems. So it was very interesting to discuss and hear all that stuff about how you index data, how do you store the data to make them the access to that data faster, how you encode the data to do that, all these optimization techniques that have to be applied in order to enable something similar to what you described. And most importantly, what the trade-offs are, right? Because obviously there are trade-offs there.
Yep.
So yeah, it was a very, very interesting conversation, and I hope we'll have the opportunity to repeat it in the future because there's a lot that we haven't covered today.
I totally agree. Well, thanks for joining us again, and we will catch you on the next DataStack show. Kishore, welcome to the DataStack Show. We're so excited to chat with you.
Thank you. Thank you for having me. I'm so excited to be here.
All right. Well, could you just give us a background, sort of your work history and how you got into data and then what you're doing today at StarTree?
Yeah, absolutely. So maybe I can go backwards and then start from what I'm doing today.
Sure.
So I'm Kishore. So I'm the CEO and co-founder of StarTree. Prior to that, I co-authored Apache Pinot at LinkedIn. And before that, I built a lot of distributed systems. That's kind of what got me excited. The world of distributed systems, where it's fascinating to see one node going down kind of renders other nodes completely useless or the entire system useless. That kind of caught my curiosity, and I built a lot of distributed systems in my career. Espresso was one of the things which is similar to MongoDB, which is the document store. And then I've also built Apache Helix, which is the cluster management framework, which is used to build other distributed systems. And then Apache Third Eye is the anomaly detection and root cause analysis. And of course, Apache Pinot, on which StarTree is built on to offer it as a service.
Yeah, amazing. What a resume of work. I almost don't know where to start. But I think one thing that would be helpful is why don't we start by talking about sort of internal analytics versus user-facing analytics, because that's a really important paradigm, for Pinot and of course StarTree. Could you explain sort of the main differences between internal analytics and user-facing analytics?
Yeah, absolutely. I think it's. I'll probably start off with, before getting to the low-level details of that, like just the concept of user-facing analytics. I mean, I was really not familiar with this term back at LinkedIn when we actually built Pinot. I was building this other system, which is Espresso, which was user-facing, but it was the OLTP workload, right, which is solving all the transactional workloads. But then LinkedIn just really embarked on this new thing, which is, hey, we have all this data that we are collecting from the users, right? And how can we actually provide insights back to them, like all the LinkedIn members who are visiting the LinkedIn website? And that's kind of where user-facing analytics really originated. And for most of you, you're familiar with Who Viewed My Profile, right? Where you go to LinkedIn, you see your page, and then you see like, hey, these are the people who actually viewed. They're from XYZ companies. They're from XYZ skill sets. Here is the geo. So it was a very interesting app that we actually started off with, right? And this was again built not on Pinot. It was actually a prior version which was built on a search engine. That's kind of where everything originated, right? So that's kind of really the concept of user-facing analytics. It's not from a use case point of view. It's very similar. You have the data that you're collecting already. The internal analytics is about surfacing that insights to your internal employees within the company. Be it analysts, operators, even engineers or CEOs and execs, right? Whereas user-facing is really taking that outside the organization, so which is to your customers, to your partners, and then providing them with all the insights so that they can actually make better decisions, right? Take another classic example, if you kind of go outside of LinkedIn, which is on Uber Eats case, right? So now you can think of a restaurant owner as a providing analytics to him as a user-facing analytics, right? Like all the orders that is happening on Uber Eats is coming into Pinot, and now that data is being surfaced in real time to a restaurant owner. Now he knows like, hey, what's my revenue? What's my wait time? How long am I taking to process this order? So this whole thing of providing insights directly to the end user, who is actually the one who is making these micro decisions that, hey, should I actually bring in another person to help me so that the order wait time actually reduces, right? Because that's directly impacting my business. So what used to happen via support before, via reports that were sent like once a month or once a day, now is being directly surfaced to the end users via interactive apps. So that's kind of really the change that we saw with user-facing analytics.
Oh, interesting. So so I actually, that makes total sense in terms of like the aggregate of like, hey, here's your weekly report on who viewed your profile, right? As opposed to logging into the app and saying, instantly, here's who's viewed your profile, so maybe since the last time you logged in. One thing I'd love to get your perspective on is are there helpful ways of thinking about internal analytics versus user-facing analytics? And I'll just give you one example. So a lot of times internal analytics are aggregated, right? So you want to know, monthly active users, you want to know, whatever trending on revenue or margin or usage or activity, whatever it is, right? What's interesting about the example you gave for LinkedIn around like, okay, well, I log in and you sort of instantly deliver this. Here's who viewed your profile. Here's their geo, whatever. Is that it's almost like each user gets their own filtered pivot of data, right? From like what internally would be a large data set, right? So it's like, okay, how many people on average are viewing, these sorts of profiles? That's more of like an internal KPI for a product manager or something like that, right? But the user-facing analytics, at least in that regard, with that example, are like pretty specific, to that user. So as you embarked on this project at LinkedIn, were there sort of new ways of thinking about analytics that you had to, sort of master in order to build Pinot?
Yeah, absolutely. I think that you brought up a very important point, right? Which is really about providing analytics in a personalized fashion, right? Like it's really geared towards that one person who is actually looking at it. What's the view that she will actually be excited? So it is to a certain extent personalized analytics, right? But there are other use cases that can be aggregated even at a different level. So if you kind of look at it at an operator level on your customer side. So if you kind of look at it at a partner, talent insights is another example that I can actually bring up, which is think about yourself as a company in Amazon or Google. Like, and you are now seeing like, hey, where are my people living? Where are they going to? Are they going to Facebook? Which area of Facebook are they going, or which area of this XYZ company they are going, and which skill set I'm actually losing people here, or where am I gaining more people? So this kind of inflow and outflow of talent is an aggregate metric, but now it is only per customer, right? So like LinkedIn provides talent insights as a product to Amazon, Facebook, Google, and all these. Now,
Yep.
if you kind of go back before Pinot, this world was basically reports based. So every month, end of the month, someone internally in LinkedIn would run a Hadoop job or a Spark job and then send out this report to them and saying, okay, here is the report that you asked for. Here is the number of people. But now it has become interactive, right? So now that report has turned into a data product. So that's the mindset that I generally see with what happens with user facing is, hey, we were generating all these reports and sending to the user. Can we actually flip this report generation into a data product so that we directly give these data and insights in the hands of the customers, right? So they can actually make use of it the way they want to. They can slice and dice however they want to, and they are directly generating insights instead of them telling, hey, this is the report I want, can you go run this report, and then coming back. So that's like the old way of solving this problem. So to a large extent, it's the problem is the same. It's just that the way you think about solving the problem is what is changing, and that's where Pinot came in, right? So LinkedIn kind of changed the way they were trying to solve this, and then Pinot was born as a result of that, because once we tried to solve that, we hit all sorts of challenges, right? I think that's something that I didn't mention in the previous topic that you brought up, was internal versus external, is like these three dimensions, which is what is the freshness of the data? How fresh is it? The one that I'm seeing, the data that I'm seeing. The second one is latency. Can I process this data? Can I ask questions at the speed of my thought, right? Like I don't want to, as a user, ask a question and then go for a coffee break and then come back, and then so those are all the things that happens in the internal world, which is you run a query, it takes a minute or two to actually run it, and it's batchy internal analytics. But in you want user facing, it's real time and very, very low latency. It should be interactive. And the third thing that is very,
go ahead. Yep.
Yeah, and the third dimension that I want to bring up is the concurrency, right? Like in internal, typically it's very few people who are actually accessing this dashboard, right? Because it's always bounded by the number of employees in your company. But when you grow out, it's limitless, right? It's like depending on how many users and how many, like LinkedIn has like hundreds of millions of users, and it continues to keep growing. Uber Eats has like hundreds and thousands of restaurants, and that keeps growing, right? So now you are seeing orders of magnitude changes in both the latency, freshness, and the concurrency challenges, right? So that's kind of why the main reason why we built Pinot, because we just couldn't scale it with the old system that we had.
Super interesting. Yeah. And that makes total sense when you think about internal users, right? Like maybe someone's looking at a report a couple times a day or once a day, right? When you think about, 50 million people logging in and needing to provide them with like a piece of data, in a couple, I don't know how long it takes, a couple milliseconds or something. That's wild. Okay. My next question, I'm actually going to hand it off to Kostas because I could keep going here, but I want to know how you actually did that and learn more about Pinot, but Kostas is way better to ask those questions. And my guess is that that's what he's going to ask about. So Kostas, please take it away.
Yeah. So I might, you might have like to repeat yourself a little bit, Kishore, because like I think the question that I'm going to ask you is probably going to overlap a little bit with the stuff that you discussed with Eric. But it is good like to put some things like under the right perspective. And I was checking like websites of Pinot, for example, and like if you try like to figure out what Pinot is, like the first thing that you will see is that it's a distributed relational OLAP database system, right? And I'd like to ask you, as an OLAP system, like how it is different compared to something like Snowflake or Redshift or BigQuery, right? Because this is like also like very typical examples of an OLAP system. Yeah. So what makes Pinot different? And most importantly, why we need to architect differently OLAP systems and create something like Pinot?
Yeah. No, it's a great question. I think this is one of the things that it's kind of very hard to just, if you take a 10,000 foot, like it's very hard to say like, hey, these are all analytical system. At the end of the day, you're asking SQL queries and then you're answering, right? So you can kind of even bubble it even more and say like, hey, OLTP systems also support analytics, right? Like, why can't I use Postgres? Why can't I use MySQL? Why can't I use any of this NoSQL document stores, right? Because at the end of the day, they're all having data and they all support SQL queries, right? I think where the differences start coming up is like the workload, the kind of workload and the kind of use cases that are that you can power, right? You definitely can't power like a very, very high throughput analytical use cases on an OLTP system. Because the way the data is organized internally, right? It's row oriented. And it's kind of very well known that you need to now shift from the row oriented structure to the column oriented, because analytical queries is not a key lookup, right? Unlike the OLTP systems, because you need to scan a lot of different data. Now you come to the analytics side. Now you have this variety of systems, like as you mentioned, the data warehouses of the world, the BigQueries, the Snowflake, and all Redshift and others, right? And now then you have this OLAP systems, which are kind of in the origin, legacy systems. People used to think of OLAP as this cube generation, right? OLAP and OLAP cube were very synonymous, right? And the data concept of data marts and data warehouse existed before. So it's kind of very similar in the sense, but some things are changed in the last decade, right? I think what used to happen with OLAP was at some point very, very popular, if you all remember, right? So you had the things from SAP and HANA and others, IBM, Cognos. So there are a lot of these OLAP cube systems. So it's important to know like the way the things have changed and how they were solved before, right? Before, what used to happen was all these cubes were pre-computed. Like every question that you want to ask, how many people from US and Chrome and Windows actually looked at my ad, right? So that was the question, and this answer would be pre-computed on an ETL job, and then it would be pushed into an OLAP system, right? And then the answer would be very, very fast. The reason why it really broke down is two things. One is there was huge explosion in storage, right? To answer, pre-compute all these things, it was very, very expensive. And two, it was inflexible. The moment you add one more dimension, everything is gone. Like all your previous computed answers is wrong. So OLAP cubing technology never really took off because of that, because there was the technology was not really made for this. Whereas the data warehouse was really good for internal analytics. The analyst could ask like a very complex join, which is like 100 tables join and things like that. But the query would take a long time, right? You couldn't really take a data warehouse and then put it to your end users. That's not what they're really made for. So they're generally about throughput, not about the latency. Like how much data I can actually scan to answer this question and how quickly can I actually scan. So their goals were actually slightly different compared to the OLAP versus the data warehouse. So that's really the three systems. It's the OLTP system, it's the data warehouse, and it's the OLAP. And Pinot and Druid and ClickHouse, I think these are all the three systems which kind of revolutionized the way OLAP is stored, OLAP is solved, right? And we kind of went, especially the rise of SSDs, I think, which helped us not to pre-compute all these things upfront. So we could just keep the raw data as it is. You don't have to aggregate it, and you can actually do the aggregation on the fly. So really the challenge is, do you do the processing beforehand, during the query? It's on the fly computation versus pre-computation. That's kind of the challenge that OLAP always had. And with the rise of SSDs and other techniques like SIMD, columnar, and indexing, you could actually say like, hey, I will compute all these things on the fly and still be able to give you like really, really good results, right? And that's kind of how this world has evolved. So now you can think of OLAP as like an acceleration layer in some cases on top of the data warehouses. But you can also think of it, because of the real-time nature, it's no longer sitting on top of the data warehouses, which is like a batch source, but it's directly sitting on top of streaming sources like Kafka, right? So that's where the freshness attribute comes in, which is, hey, I can't wait for someone to take the data in Kafka and other messaging systems, do an ETL, put it into data warehouse, and then get it into the OLAP, right? So that layer is getting short circuited right now. So you like point at your streaming source, the moment a data event is created, we can ingest it, and then we can directly serve it to the end users. So I think there are a lot of these changes, a lot of variables that changed in the world that kind of resulted in creation of these systems. And the nice thing is it empowered the product guys and everyone else in the company to think of things that they had not thought about before, right? Like if you look at LinkedIn, it's serving 200,000 queries per second on Pinot today, right? It's huge. It's like almost taking OLAP workload, and you are actually OLAP system, and you are actually serving OLTP kind of workload. And if you look at internal analytics, it's hardly single digit queries per second, right, across your entire company. So it's a day and night difference in terms of what you can accomplish with something like Pinot versus something like the internal data warehouses. Sorry, that was a long answer, but I think these dimensions actually matter a lot when you actually deep dive into what are the use cases and what it empowers and enables a company to achieve.
100%. And I think like it's important to have like these conversations and put things like under the right perspective, because even I think like for data engineers out there, it might be hard like sometimes like to understand what are the differences and why they might need like not just like a data warehouse, but also like a real-time OLAP system and vice versa, right? Like it's and we take, like people that have been like working with that stuff for a long time take like all these things like for granted, but they are not, right? Like, so that's why I said, and I was expecting that there's going to be like some kind of overlap with, because you talked about like freshness, the latency, the concurrency, like all these things that, I mean, I remember when I first used Redshift, and like you could see that like Redshift was back then was supporting like, I don't know, like 100 concurrent queries maximum or something like that, right? And then you had to start using like queues and things like this to do your analytics, which made total sense because it's a system that is built like, as you said, like go through a lot of data, many queries that take a long time like to compute. But okay, how many users you are going to have, right? Right. So it's all these trade-offs that at the end they give like a different system as an output, and that's what I'm trying like to emphasize here, because these trade-offs are like very very important for us like engineers like to understand. Okay, so what's the secret sauce? Like, how do you take a system like, I don't know, like a data warehouse system as we were used, and like turn it into something that it's OLAP but has also the performance, let's say, of OLTP, right? So how does Pinot do this?
No, that's a great segue into getting into the internals, right? I think, but I'll try to like start from the high level and then just deep dive into like what happens, right? I think let's take a query, for example, like what are the phases in the query, like when someone runs a query on a database. So typically a query has a filter step, which is you have a predicate in the query, and then it tries to solve the filtering part. And the second one is like the scanning part after that. Like once I have filtered and narrowed it down, and like, okay, now I need to scan a bunch of data, right? And then the third part is really the aggregation or the group by, like what kind of operation are you doing on top of it. So you kind of break down most of the query into these three phases. Again, there is a join and other things that come on the top, but I'm going to keep it simple for this, right? Right, it's really filter, project, and aggregate and group by. So that those are the three phases. Now, if you kind of look at how data warehouses did this, they just on the filter phase, it would always be brute force, right? It's like I'm going to scan as fast as I can, and I'm going to filter it, right? And then yes, they would have some additional metadata that they would try to keep, like min max and then bloom filters and things like that. But they were all at a high level. A sparse index is what I would call, right? It is, can I eliminate like some chunks of data, right? But what we found was that was not scalable, because there is very hard for someone to actually say that, hey, predictably saying that, okay, my filter is going to take X number of seconds or X number of milliseconds. And for us, it was very, very important to have that predictable latency. Like if you are looking at who viewed my profile page, we have a 99th percentile latency, which is less than 100 milliseconds. So we would get alerted if something goes beyond that, right? So we had to make sure that we put in all these things to solve that, to address that latency requirements. So that's where indexing comes into picture. So now you go from the scan-based filtering to actually index-based filtering, right? And that's where Pinot shines a lot. So it does two things. One is it rearranges the data automatically so that you get memory locality first, because in terms of personalized analytics, you can automatically rearrange the data internally to make sure that all your profile views are stored together in the same place, so that in one seek I can actually get all your profile views instead of just staggered and then have to do like a lot of different seeks. So that's the first optimization that we do, is we automatically reorganize the data as they are coming in, right? Which is a very, very important thing for us to make use of the amount of seeks, minimize the number of seeks that we need to have. And the second one is the indexing, right? We go from like sparse indexing or like block level and like chunk level indexing to get into like row level indexing, very, very fine grained. So I can exactly tell, hey, these are the rows where your profile views are placed. These are the segments in case of Pinot where we can actually get into. So it's really about that filtering phase, right? Like how efficiently can you prune down a lot of data so that you don't have to do the work. So the philosophy, if you kind of look at this, is the data warehouses on all these other databases try to do the same work but faster by trying to use SIMD and all these other techniques, right? But the philosophy of Pinot is like, hey, can we not do the work, right? So that's kind of where the indexing comes in. It's about eliminating the work rather than doing the same work faster. So that's the most important one in the filtering phase. Now, that's where indexes come into. Like Pinot has like tons of indexes, right? Like it for every use case, every kind of thing that you can think of. If it is a range index, it's we have the range indexes. You can say like, hey, tell me all the queries that are more than 3 seconds, right? Now a classic inverted index will not work for that, but you have something called as a range index, which quickly knows like, hey, these are the rows that actually have more than 3 second latency. You have inverted index, which is classic, which is probably something common to all the other systems. We have text indexes, so you can index text. You have JSON index, so you can actually do that. We have geo index. So there are tons of indexes like this, and that's kind of how we architected it. Is like the indexing schemes itself is pluggable, so you can keep adding more and more indexes. And we have added a lot of indexes over a period of time, and then we continue to keep adding more and more there. So that's kind of the innovation that we did on both the storage layer and on the indexing layer, right? And then the next part is the aggregation, right? In terms of, hey, how can, if the after the filtering, how can we make sure that the aggregation is faster, So there again, there is classic techniques of making the scan very fast. But Pinot introduced another technique called a StarTree index, which is kind of how we named our company as well, based on that indexing technique, because it makes things so much faster, orders of multiple orders of magnitude. So just to give you an example, right? Let's say a classic case is how many ads did we show in US? Let's say someone asked that. And typically what happens is in any company, your 50% of your ads are probably coming from US, right? Compared to the rest of the world. So even if you're indexing, you have the indexing technique, you will have to end up scanning 50% of your data, right? What is the revenue for US? So that's where StarTree comes into picture. So StarTree analyzes this data upfront, and then it automatically figures out that, hey, if a question comes for US, it's going to be very expensive if a query comes. So I'm going to pre-compute only for US. But if it comes for something like Kenya, which is you don't really have to pre-compute, it can actually do the on-the-fly computation. So it's going to do on-the-fly computation for Kenya. So it has this smartness built in to actually figure out what needs to be pre-aggregated and what can be aggregated on the fly. So you don't have to explicitly say that, hey, aggregate for US, aggregate, don't aggregate for Kenya. It profiles the data as they come in, and it creates these smart indexes on top of it. So it's like this enhancement and innovation at every layer, from storage to indexing to aggregation. And even there is a lot of pruning that happens in the broker. Like, how can we minimize, how can we eliminate the work? So it's across all these stacks that we have actually done the optimization that actually gives us the speed. So there is actually a nice blog on like what makes Pinot fast, and we have listed out all these different techniques there.
Okay, that's awesome. Okay, follow-up question to that, because it sounds like, okay, almost like too good to be true in a way, right? Like, why do we need Snowflake if we can have like something that's like as fast as OLTP and at the same time is an OLAP system, right? So what are the trade-offs? Because when we are engineering, we always make trade-offs, right? So what do we lose by adopting, let's say, and using like a solution like Pinot compared to the traditional lab system like Snowflake?
I think there are two things. That one is the flexibility of queries, right? Definitely Pinot is not built as a data warehouse engine, right? Like, Pinot is not going to support like 100-way join. I mean, we don't have joins as well, right now we have lookup joins, and then we are adding the joins as well. But again, the key thing for us is to make even joins faster. So we are going to address the cases which is where joins can also be predictable and very, very fast. So we have some innovative things that we are actually adding on to the join layer that will help us even solve some of these join use cases. But again, keeping in mind very, very low latency, right? And data warehouses are really made for the analyst who can actually write 1,000-line SQL, right? I cannot really parse that, but that's the purpose for data warehouse. So you have like a lot of different tables that need to be joined. So Pinot is definitely not built for that, and we don't intend to go there as well. We want to make sure that we solve one use case and solve that really, really well. So that's one. And the second one is the cost aspect, right? I think it's so you need to have a certain level of usage for this to, because one of the things with Pinot is it's again, this is changing, but it's a tightly coupled system. So that means you pay the cost for storage and compute, because the compute is always running, right? Unlike Snowflake, you can actually bring up the compute when you want, when you're running the query, and only when you're doing it, you pay for that, which is good. It serves a particular purpose. But you can't do that for user-facing analytics. You cannot say that, hey, user came to who viewed my profile page. Now I'm going to spin up the compute to actually answer this. So it's that breakpoint. So you typically, once you get to like tens and hundreds of queries per second, you end up actually needing something like Pinot, because the other side becomes a lot more expensive because you're paying per query, right? So you want to really look at, if you see the two systems, it's like the cost per query. The cost per query in Pinot will be hundreds of magnitude lower than the Snowflake, but only after a particular scale. Like, you need to have that level of concurrency. You're serving your apps, you're serving your users, and then you start having that break-even point at which Snowflake and other systems will become super expensive, right? And
Mhm.
the key thing to realize there is it's kind of a chicken and egg problem. So sometimes you try to build your user-facing apps on these data warehouses, and the latency is bad. You won't be able to add also. You won't have the freshness. You won't have the dimensionality that you need for your app, and then your app never takes off. Right?
Mhm.
And then you say, okay, I'm okay with this. But the key thing is like to make sure that the users get what they want, and then you will see the concurrency, the number of requests actually go up a lot. And that's kind of what we see. Like as I said, like LinkedIn is solving like hundreds of thousands of queries per second on top of it. That's because you provide an app to the end user, right? You're not writing SQL queries against this. A restaurant owner is not writing SQL queries. It's very different in terms of the way people interact with something like Pinot versus the data warehouse systems. So you always want to think of in terms of apps, like what apps do I build on top of Pinot? How do I actually showcase this value to the end users? And that should always be through apps and not providing them with a SQL editor and say like, okay, go write your SQL query here. And that will never work. And then that's also probably the wrong way of using something as powerful as Pinot.
Okay. Yeah, makes total sense. So you mentioned before two other vendors outside of like StarTree of like Pinot's also like ClickHouse and Druid, right? And I think Druid is probably the oldest one, or am I wrong on that?
I think you're right. Druid is probably the oldest one. And I would say, I don't know, Elasticsearch was probably there. I think that's also something that people use for analytics. Even though it was not purpose built for that, it was really built as a search engine. But when you have an inverted index, you can throw in anything at it. So a lot of people ended up using Elasticsearch as well.
Yeah. So what's the difference between these three, at least, like different tools? Give us like a little bit of help us to understand the landscape, like understand like the vendors there and what are the difference.
Yeah, I think the key thing for us to look at is the evolution of analytics itself, right? I think then it kind of becomes apparent on where Pinot shines versus the other system. So the world went from like pure batch analytics to real-time analytics, right? So that's where Druid came in, right? And I think ClickHouse added a little bit of the Kafka connectors and other things later on. But it was really going from batch to real-time is where these two systems came in. And where Pinot is coming is going from real-time, low concurrency to external with high concurrency and predictable low latency, right? So it was kind of the freshness was the first factor which drove Druid and ClickHouse in the beginning. And then latency seconds was completely fine, right? And with Pinot, we are actually going from, we still need the real time. That's a stable, that has become a table stake right now. But now you are adding other dimensions, which is it has to be millisecond response time and be able to serve very, very high concurrent requests, right? And then be able to be predictable about that. So it's really when you draw the graph of latency versus concurrency is when you start seeing the differences between these systems. So Pinot is able to keep that low latency as the workload increases. And whereas the other two systems were not really made for that in terms of the low level system design, as I mentioned about the fine grained indexing, right? ClickHouse still has sparse indexes. It doesn't have the fine grained indexes that Pinot has. Same with Druid. Druid has only one level of indexing, which is the inverted indexes. It doesn't have all the other indexes that we mentioned. It doesn't have the concept of StarTree indexes and others. So it's kind of, we are kind of very, very focused on providing predictable low latency at any scale. Whereas both Druid and ClickHouse, the main purpose was to provide low latency for the internal use cases. That's kind of where they really started. And that was the key premise behind their design.
Okay, yeah, that makes sense. And that's actually interesting. Like the differentiation there between like the internal and external like use cases, because concurrency is important there. Like you need to have like really high concurrency together with like the low latency, like to do that. Okay, so let's go back a little bit to the technical conversation that we had about indexes and like all that stuff. So what's the experience that like the user has like with setting up Pinot right now? Like, okay, you give like all these options in terms of like the indexes that you can use. You also have like a smart indexing system with like the StarTree that you mentioned there. How much the user is like responsible for making Pinot as fast as it can be, and how much of this is automated?
I think our first, we would definitely want to take these in phases, right? Like we don't want to try to become too smart there in terms of figuring out the indexes automatically. So our first option was to always have knobs. I mean, this has been what databases have done all through the world, right? In all like decades, like you have an alter table and you can add indexes, right? I think what we took on is like, hey, these are all the features that we have. Here are all the knobs. You have the control in terms of what are you trading off, because adding an index comes with the cost, right? If you are adding a little bit of a storage overhead there, but now you are trading that off for, hey, I'm going to get like amazing performance. So we kind of have this complete flexibility. That's kind of where we went, is like each column can actually be of any type. It can be encoded in any way. It can be raw encoded, it can be dictionary, it can be run length. So you have all these options that we give to the user. And each column can have any type of indexes. It can have inverted index, it can have range index, it can have JSON index, like whatever that you want. And even the type is very flexible. So it can be a strict type, it can be int, long, and etc. It can also be a semi-structured JSON. So now you have indexes on the JSON as well. Or it can even go further and it can actually be a text index, right? It's like completely unstructured. So you can go from structured to semi-structured to unstructured.
Yeah.
We kind of give that whole flexibility to the user. Now, again, that now comes with an onus on the user. Like, oh my God, what indexes to configure here? So the way we approach that problem is really about giving them the insights when they run a query. So they can, the way we advise is like, don't try to configure anything, because everything can be changed dynamically when the system is running, because this is something how we built and operated the system at LinkedIn. So all of these indexes that we talked about can be added dynamically without having to re-ingest the data. So you can just ingest the data as it is. Don't worry about the performance in the first shot. Run a query, and then we, unlike traditional databases which provide like a explain query plan, and say like, okay, these are the things that are actually slow. We actually embed that in every query. So when you run a query, you get the response. You will know exactly how much time was spent in which phase of the query. Is it the aggregation phase? Is it the filter phase? Is it the project phase? And then based on that, you can now go back and say like, okay, I'm spending a lot more time in filtering. What column am I spending time on that? And then what indexes that I can actually add. So it's more reactive than trying to be smart about it. But I think these are some of the things that we plan to make it easier with the StarTree version of Pinot, where we will constantly keep analyzing the queries, and then behind the scenes we'll say, okay, this is what needs to happen for this, and we automatically set up those indexes so that users can actually automatically start seeing better performances. So it's that the learning and application of those indexes is kind of outside of Pinot, because we don't want to do too many things automatically. It just confuses the user there.
Yeah, of course. Okay, it's time for me to give the microphone back to Eric. One last question. Share with us something like exciting about Pinot or StarTree that is going to come like in the next, I don't know, like couple of like weeks or months or whatever. Like, what's the next exciting thing that you are very excited about it?
Yeah, I think two things, right? One is definitely the tiered storage, which is a big design change. It is not easy to change this design in systems that are 5 to 6 years old, right? So if you look at all these systems, they are tightly coupled. Pinot drove it, ClickHouse, the storage and compute is tightly coupled. And now we actually announced a decoupled version of that, right? So now you can say like, what tables with like one system, you can select, hey, these tables should be local, these tables should be remote. So then now because one of the things that users were asking is like, hey, Pinot is so fast, how can I keep the data much longer and I don't care too much about the latency for the old data, but I want like very, very fast latency for the recent data. But
Yeah.
now I don't want to take this data from one system to another system and then keep moving these things around. Like, can you actually make it fast in the same system? So that's kind of where the tiered storage comes in. So you can say for 7 days, I want the data to be local. And as soon as the data is older than 7 days, do it decouple so that it goes into S3 and the queries run directly on top of it. So that's something that we are super excited about. So now you can keep the data in Pinot for how much ever longer you want. And then when you have like the queries coming for the older data, it's going to be slightly slower. Instead of like tens of milliseconds, it's going to be hundreds of milliseconds. But that's acceptable. But you're now able to trade off between the cost and latency. So that ability to trade off between cost and latency was not available before. And now we give that another level of flexibility to the user in terms of picking one versus the other. And the second one is join. We are in very early stages, but we are coming up with like some really cool ways of doing joins, unlike the other systems, in terms of being able to do joins in a streaming manner. Right, and that's something that's going to help us in terms of addressing some of the user-facing analytics use cases where you just need a lookup join between the two, or you want like one stage join between two tables. So that's something that we are also super excited about.
Super cool. All right, Eric, all yours.
All right, one more question since we're close to the buzzer here. I'm interested to know, I'm just thinking about our listeners out there who are listening to you talk about user-facing analytics and speed and all these other things, but are wondering when should I adopt a technology like, Pinot, StarTree, at what point, or what are the signals in your mind that indicate, okay, you should sort of look at this? Are they related to scale? Are they related to sort of, complexity? Like, when in the life cycle, say, of like the growth of an organization, what are the indicators that, that this technology is appropriate to implement?
Yeah. No, I think that's a great question. I think 2 years back, my answer would have been very different. I would have said like, hey, until you grow like LinkedIn, don't use LinkedIn or Uber. You don't need Pinot. But that's changed drastically in the last 2 years. I think there is a lot of value that companies actually have unlocked. That is hidden in the value data that they are collecting. But that's not unlocked to their end users, right? Like, look at all the small startup companies that are there, right? And they are collecting huge amount of data from their customers, especially the SaaS vendors, right? And now what are they doing with the data? They cannot just say like, hey, give me all your data and I'm not giving anything back to you, right? So now they're forced to think about like, hey, what is more value that I can actually provide on the data that I'm collecting? So they're building some sort of a data product so it really starts from there. It's not about the size of the data. It's not about the complexity of the queries or any of those. It's really about what more value can we extract on the data that we are collecting. So that's where it starts. Like, what more better decisions can we allow? Like recently, I mean, this is a case of Cisco, which is kind of big, but even if you look at Cisco, the call that is happening right now, right? How long did you talk? How long did I talk? That's a useful analytics to have, right? Like across all your podcasts that you have done, like it would be so cool to get analytics on top of that, right? Like, and what was the tone? How long did each one talk? All sorts of analytics is actually very useful. So it's really about, hey, we have all this data. We have been for decades thinking about providing insights to our internal employees within the org. Like, how can we do something better than that, right? Like, how can we give it to the people who can actually make use of this data and then make better decisions in their life. So that's kind of the mindset I would start off with. And once you start seeing the patterns, it's not that hard to actually find out that there is so much more value that we can extract out of this data. And that's kind of where I would start with.
That's great. Yeah, I love that answer because I think it's a good example of how technology that's built for sort of super scale enterprise, if you want to call it that, trickles down and becomes democratized, in a way for lots of companies to use. So super exciting. This has been such a wonderful conversation, Kishore. Thank you for joining us and giving us some of your time and teaching us about Pinot and StarTree.
So thank you, Eric. And it was really good to be on this call, and then I completely enjoyed it. Thank you for having me again.
Absolutely.
All right.
Welcome to the DataStack Show prequel. We just recorded a fascinating show with Kishore. He is one of the founders at StarTree and was one of the original creators of the Apache Pinot project, which can do user-facing analytics at an unbelievably massive scale. He developed that at LinkedIn. Kostas, it was such an interesting episode. What really stuck out to you from our conversation with Kishore? I'm going to let you go first this time because I usually don't do that.
I really enjoyed the technical conversation that we had. Systems like Pinot have some very interesting, technical choices because they have to deliver, very fast results, but make sure that they can also support crazy concurrency. And it was super interesting for me to go through the choices that they've made to achieve that, and also what the trade-offs are. It's sometimes you hear about, you say okay, we have Snowflake, we have BigQuery out there, and then you have something like Pinot or ClickHouse, and you're okay, why not just use these? They sound okay, data warehouse on steroids, right? Why do we need both?
Yeah.
And there's a lot of noise out there. It's not always easy to understand the differences. And for me, it was extremely enlightening today to understand exactly what the differences are and why at the end we probably need both of them because they serve different use cases and they make completely different trade-offs. So yeah, that's what I keep from the conversation today, and I'm really looking forward to talk with more vendors of this space and learn more about how we build the systems.
Yeah, absolutely. I agree. I think one of the other things that was interesting was, Pinot is used by really large enterprises, a lot of them, right? But Kishore said, and it was fascinating, he said that his opinion has changed on sort of the scale you need in order for a system like Pinot to be useful to you. Mm-hmm. He said, really, it's becoming more valuable and easier to run for smaller organizations and smaller data teams as well, which was super interesting. So definitely listen to the upcoming episode with Kishore about Apache Pinot and StarTree, which is built on Pinot, and we will catch you on the next one.